14. It's been an interesting 17 days, guys.
Yeah, very much.
Okay, so
Yes, I can see your screen.
you can see it, right? So during the previous
Yes.
session, day 14, it was on Friday, we were working on this double story where we did the CADs in AutoCAD, we did the column placement, and then when we modeled in Prota, we realized that because here in AutoCAD we were proposing that because on the ground floor these columns are sitting okay, but then on the first floor they are coming out. So previously in the previous video, what we decided to do was to make them not go all the way. But then when we look at it, the way that we modeled it, if we were to delete this and just put one long one, it seems as if it can be a very long beam because this is from grid line 01 to 04. Yeah. So if I go to the plan view and I measure 01 to 04, so you right click, you use your measure tool, you go there to there. It tells you it's 801. I don't know where it's getting these 01s, but it should be 8,000. Let me try again. I don't know what's happening. If it's nothing from there to there, if it gives me 801. Oh, okay. Let me try to measure from the AutoCAD file. From here, right? I don't know why it's giving that 01 at the end. From there to there, also 801. Can you imagine? Can you imagine? Okay, let me just pull out my calculator. 3,200 plus 1,800 plus 3,000. It's 8,000. But why is it giving this zero? Hmm.
Okay, I'll try to measure from mine. I'm just switching on my PC.
Okay.
I'll try to see.
But you remember I shared this, man. They might just give me the same thing. Oh, this is 5. Good. And then what's wrong with this one? Ah, this is the culprit. But this come out proper. Yeah, so what we've decided to do, so that we do not take a long time here, what we've decided to do is to change the orientation. I don't know whether to try to do the analysis, just run it like that and put the brick, the wall odds. But I know for a fact 8,000 by 200, it's extremely risky. Although alternatively, in if we do building technology, it can work because it will be resting on walls if we were to do that. But that's a little risk. Still, the beam will be deflected. So just for our own safety, what I would recommend is we change the orientation of these. So and you have to do them at the bottom. So what I'll do is I'll just go back to my ground, and then here I know which axis are they? I know it's on axis 3 and 4 and also 6. We'll try to rearrange them at 3. I'll say let me go to this one. Is there one that doesn't have any eccentricity? Okay, since I already have one some that are existing, I'll choose select this one right click. This is edit. No, I cannot work. I cannot work in the ground floor, so I go to. I cannot work on the foundation. This is the foundation, so I'll go into the ground floor. I'll select it, properties, and then I can duplicate something similar. Here already you can see that it's given an eccentricity of 100. It's because of this car space. This one. If you move out, you measure from this edge to this edge. It says 100 there. It's eccentric. It's off center by 100. However, for the ones that I want to create, I do not wish for them to have an eccentricity. So I'll just say 0, update, and then now it's at the center, the snap. So I'll put it there, and I'll put another one here, and then I'll also put another one. I'll also put another one here on 6, like that. And then I'll go to the 3D, and then I'll check that I've got 2 columns right now. So now I need to delete the ones that I do not desire anymore. For example, this one I'll delete it, this one I'll also delete it, and this one. Now I can generate these to the next. Remember how many places? Oh, up to the just this top. But it means these will have to remodel them because they'll get into the way. So what I'll do is I'll select one, hold control, select the other, hold control, select the other. No need to let go of the control. Right click, says generate to other stories. The X shows the placement, the X. And then the other ones that you select are the ones that will have. So if I click here, if I like, I can hold the shift and I'll click everything and I'll OK. It will ask me this and the previous processes will not be undone. Do you want to continue? Yes. So when I hear some of them have been cancelled, saying they exist already. It's just that I cannot control Z because it told us. Okay, so what we can do is just we can go there and delete them like that. Even there, here we already have one, so we are good. Even here it's put one. Even here it's put one. So what we can do, we can go to the ground. Is it the first floor? The ring beam. Let's see. Initially we are placing them here, right? Initially we are placing them in the ground. 3, 4, and 6. I'll go to I'll go to the first ring beam there. Here you can see there was one, but it's been moved. So 3, 4 here. I'll delete this one. I don't like the way that it is. And then I'll go to, I can select this one again, properties. Still this one has an eccentricity. I remove, and then I'll put at 3, at 4, and at 6. Previously what you were seeing, what the beam was doing there, it was doing as if the direction of the loading, and it was showing that it's going in both directions because it doesn't have any support there. But after having placed these columns, you can see that that sign has disappeared. We'll see it on the other floor. Let me just control S, and then I'll wait for it to finish, and then I'll change my view to 3D. I know there's another layer, another portion that needs. We're here, right? In this direction. So we've got these two, but this one doesn't have. I'll delete that one. If someone is requesting to join. Hello. Okay, so we have just placed this as a first string beam, and we are going down. Yes, good evening, Ian. How are you? Okay, I hope that you've been following the videos that we've been doing previously. If not, I would highly suggest that you watch 13 and 14 because today's content is based on what we've done on day 13 and also day 14. So, as I was explaining, these columns that we've just changed the orientation were on the first ring beam. So now, even you can see now, these axes are appearing on the first ring beam. What I can do is when I go to your first floor and then I change my orientation to a plan view, you can see that at 3, 4, and 6, I do not have those columns. So I'll do the same, right click, select that one. Oh, this is left click, right click, properties, change the eccentricity to 0, and then I'll update. Oh, it's changed this one, Control Z. Remember, you select that one, right click, properties. Now this is the one that you can change the 0 like that, and then you put it there. Oh, okay, there and there. Here already I can see that just by the virtue of selecting using that one, it's changed the eccentricity. So I guess it also happened on the ground, first, and ring. So this one I need for it to just remain at an eccentricity of 100. So this one I'll add it like that so that it flashes with a beam. And then this maintain. I'll go to my first ring there. This one changed by the virtue of having changed the other ones. Okay, these are flashing. And then I'll go to the ground also. I'll select this one, properties, give it an eccentricity of 100, and it moves 100 to the right like that. So now hopefully all of them are good. I'll change my view to 3D and then I'll check. It's here, we're working here. You can see that all of them have changed. 3, we're 3, 3, 4, and 6, right? These, all of them have changed. And now my concern won't be that they'll be coming out of the wall. Yeah. So these bottom ones have changed. Even this one, only this one. We need to go to the second and the roof. And in fact, I'll delete them right here in 3D. Select, delete, and then I'll go to second ring beam, change my view to plan view. You can see it there is nothing. I'll choose this one, select there, place it there. On 6 it's okay. And then on the roof, you can see that it's missing. So I'll select it, properties, and put it there. I'll go back to my 3D just to confirm. Remember 3, 4, and 6, right? So my 3, okay, all of them are good. At 4, they are good. At 6, they are good. If you would also like to change in the AutoCAD file, you can just quickly go in there and then either you can move. Okay, let me show you the way. In fact, I'll start on the ground floor. Here, let me just delete them. I'll delete this one. Remember, it's 3, 4, and 6. Delete that one. 3, 4, and 6. And then here, I'll use this one. When I highlight it, I'll move it. I'll use the move function. And then I'll hold it here. I'm in ortho, so it won't be able, it will only move in the x in the at 90 degrees or 0 180. So when I deselect ortho, it comes like that. And then this one also I need to delete it to change the orientation also. This is the one at 4. At 6 also we need to delete to change the orientation. Okay. So now I'll select this, maintain my ortho, rotate. I'll give it a rotation of 90 like that. And then now I can place it. So guys, just by observing here, it has an eccentricity of 100. You can see, right? In fact, minus 100. So I'll select it there, I'll copy, I'll pick it from this edge and then place it here and also here. These are good. But for number 4, I'll have to change the peak point. This is my peak point now, and I'll put it there. So just to make sure that they match, I'll select all of them, this one and this one. Select this one also, and select this one. And then I'll copy at 3. I'll say copy, we're moving from the first floor here, the ground floor, to the first floor. So I copied from 3. The peak point was 3. So I have to paste it at 3, like that. Yes, that's why it's giving that error message. You've seen that little, it's off. And even this one is slightly off. Okay, so now I've moved them from the ground floor, I've moved them to the first floor. But at 3 there is a column. At 3 there is a window. At 3 there is a window. If that's the case, now just I'll move it here. I'll move it at 2. It's a lot of work. Let me try to look for the midpoint. Okay, I'll select this, move it, and then I'll delete this. It doesn't make sense being eccentric there, but it's there. So 4 has to sit like that in order for 4 to sit like that. This one I put it on the middle. Number 4. Okay, so if number 4 sits on the middle here number 4 won't be able to sit in the middle because there's a window. So I guess we need to maintain the eccentricity of 100 on number 4. However, since at 3 on the first floor there's a window, I'll put it at 2. How about 6? Let's see. 6, can it be in the, here it can be in the middle. Here it cannot be. So this one I'll move it at 2. Move. Can't find the center. Let me draw the center. I click line, shift, mid between 2 points. I'll select that and that. Make sure my author is on, and then I'll leave it there. And then also I'm trying to create an intersection. Line, shift, right click, mid between 2 points. This one, and this one. All this work just to create a pick point. So when I click move, I'll choose this one here, remove my author, then put it at 2, like that. So now here my 2 has to here my 3 has to go. My 3 on the ground floor sits okay. My 3 on my first floor cannot sit okay. It's in the wind. Therefore now we change the spans. This will be like 480, this will be 320. So meaning now we've changed the entire design, column placement. I'll select that and delete, and then I'll copy at 2, this one. I'll pick it from, let me pick it from here, and then paste it here. Ah, there's also a window here at number 2. Okay, so this is 8. Oh, we cannot have a floating column. At 2 there's also something. Okay, let's go. We'll increase the depth. We'll see. We'll have to run an analysis. So we've tried all that we can. We found that only on 4. You guys are here. Okay. Oh, there's a message in the chat. Oh, hi. Yeah. So we go back to our Prota. At 4, we give it 100. We'll start with the ground floor. Change your view to plan view. Remember, 4, we give it 100 eccentricity. 100, like that. So that this 4 in Prota will match the 4 in AutoCAD. AutoCAD first floor, AutoCAD ground floor. And then from there, the 6 can be maintained, right? There's a 6 there, can be maintained. Even here, it can be maintained. How about the 7 can be maintained also? Can be maintained. So remember, I've only changed the orientation on the other ones. If I like, I can change in 3D. We're at 4, right? This one. You can see this one. This one has moved by 100. So I'll give this one also an eccentricity of 100. Now they are in line. I'll also move this one to give it 100 eccentricity, like that. And then I'll move this one also, properties, 100 eccentricity, update, and this one too, 100 eccentricity. Okay. And then we've decided that at 3 we are deleting. We can delete the top one, the bottom one can remain to help support the slab. Because from the bottom, 3 is good, but it's at the corner there. 3 is good, but at the top it's not. So what I can do is I'll copy and change the orientation. So there I copy it, I put it, this is a -100. Previously we were going in the right direction, so it was a positive. Now we are going in a negative direction like this. So we have to say -100 eccentricity. And then on the third floor we will not put 1. So I go back to my Prota. I say My 3, I give it a minus 100 centuries. Oh, this one can remain. Doesn't have to. It doesn't have to be centric, does it? Yes, it does. This is 3A. 3A. Let's see. Okay, I'll have to give it a 300 minus 300. Click properties. Give it a minus 100. See how it moves. It moves there. I'll close. Go here. Properties. Give it a minus 100. Update. Also this one. A minus 100. Update. Close. This one is the one who said doesn't need to be there. Okay, now they're in the same line, they are passing. Also, by that virtue, this one will not be there. Well, now it's slightly better the span, but I still need to delete this one. They cannot be two like that. And then I'll go to my roof. There, change my view to plan view. Here where it's splitting, it's right here. I'll delete it like that. Even this one, I'll delete it. Someone who should be there. And then I'll say properties. Since for now I'll maintain the same section. No, I don't content request. Okay, I guess even here it will have to be. How does it look like on the ground floor or the first floor? On the first floor here there's a color, but can it 3B? Let's go to 3B on the first floor. There they're saying it cannot sit like that because it will enter the room. But how about, yeah, so the room boundary is here, you see. So it's infringing on the first floor. How about on the ground floor? Can we change? How much is it? At 3A, 3B. It's 3B, isn't it? Okay. But we cannot change the eccentricity on the ground floor or the layout and maintain the. So even this one will have to rotate. Make sure your author is on. And when you do that, and then you can move it from here to here. And then you can copy it like that. You can copy it. You pick a point here, and then you put it there. So meaning it will sit like this. And therefore this we need to delete. Okay. And then that means we can maintain this column, which is actually most comforting, because if this is our primary and secondary can get into the primary here, but it will be supported here. So I'll go to my Prota, change my view to 3D. Remember that we were working on 3B. So I'll go to my 3, my B is here. I know that, okay, let me go to plan view, ground floor. I know that I have to change the orientation of this one. In fact, yeah, in fact, I'll just delete it and copy and duplicate the properties of this one. So here, just save it. But as it saves, let me try to check if there are other columns that will need rotating. In B axis there's nothing. Okay. So I've changed the orientation on the ground. I'll need to change the orientation on the ring beam level. I'll select it like that. Properties, 3B, and then if you'd like to see how that looks, in fact I should have split the screen. Sorry, let me split the screen so that we can have a 2D and a 3D so that we can be working and seeing things changing. If you remember from our old videos, splitting the screen was on the window tab here, and then you say tile vertical. When you click it like that, remember you only have one view, so you need to add another one. Yeah, you add a 3D, and then you do the same, and now you have something that looks like this. So where we're working from is here at 3B. I know this is my 3, like that. I can see where things are changing right there on the 3, and then I know it's on my B here, so I'm not lost. So I've changed on the ground floor there. I've also changed on the first floor. Now I'll need to go on my ring to change it. I'll select this window or this section to activate it. Pay attention here, when it's dark or it's bold, it means you are working in that space. For example, this one currently is not dark. When I double click, it changes. This one fades, and so on and so forth. But I want to work in here, and it's on the, let's see, on the ground floor. We are good. How about on the ring? On the ring also should be, we are good. Where is it? Yeah, that one is selected. The ring is there. How about if I go to my ring in here? I go to my, oh, we changed the ring. We're on the first, and it's this one here, 3B. I'll select it, delete it, select this one, properties, and then I'll put it here. And then we have some changes there also, you see. So now the question should be whether or not it should continue. You consult your AutoCAD file. Can it continue here at 3B? Shows that it can. Therefore, I'll pull up my Prota again. I'll go to story 4. Story 4 is the second ring beam. I'll select like that. As you can see, there's nothing there, but we'll put one. I don't have any one with similar properties. Okay, what I'll do is I'll go to my column here, and then, yeah, with a minus. Okay, so 3B, watch the 3D that side. I put it, it appears there. And then I only need to go to story 5 here and do the same. Select, go to story 5. I can see that there is nothing. Click on my column, put it there, and there in my 3D I can see. So I've mitigated some of those problems that we had here because of the architect's placement of the windows. Also this one, this beam, I need to delete and go to, yeah, it was 2 cut beams. I'll go there, delete, and then where should I go? First ring beam. Here, first ring beam. You can see this one says 200 by 200. I can tell. Oh, it's a second ring beam, sorry. Second ring beam, there's those beams that we've removed. So I'll select it, properties, and I'll put it like that up to there. And now I have a straight singular beam instead of the ones that were there that were two.
Mr. Shura,
Uh-huh.
between A1 and A4,
That's your AutoCAD.
isn't the span too? Yes, between A1 and A4. No, in Prota.
Okay. Or the same one that we've just put.
Yeah, the span. Isn't it too long without any support?
Okay.
Because for me, it's showing me it's 8,000.
Aha, very good observation. So let me go back to my DWG. Here it shows that it's really 8,000 because 3 2 plus this one will be 4. Is it 8 or 9? I've got 3 plus
It's
3 gives
8.
me 6 2. Yeah, plus 1 gives me 8,000. Correct. Because 3 2 plus 1 is 5 and 3. Okay. So, Paul, your question is this is so long, we need a support. When you remember when we were just doing the column placement, we put a column here on number 3. And because we wanted it to span from 1 to 3, then 3 to 4. That was the original idea. However, this layout, this column placement on the ground floor is okay. If I get this same column A3, if I get it from the ground floor and I put it on the first floor, it shows that there is a window. You see?
Yes, yes.
So meaning if I get this column here, column A3 from the ground floor, and I make it run all the way to the roof, it means I've destroyed the architect's intention of putting a window here. You see it, right? So that's why when you see in Prota, I've got a column starting from there and then it goes there. But here at the top, there's nothing. So now I'll try to model it like this as a 200 by 400. But I can come and try to make it deeper. Maybe a 200 by 600 after running the analysis. I hope that answers your question.
Okay, we'll see if
Yeah.
after the analysis.
We'll see. So here, I'm just trying to compare if there are any protrusions because they do not want these columns sticking into the room and making that corner. So we want to hide all of them in the walls. So in this line in A, everything is good. In fact, here let me remove it. It won't. Oh, on the ground floor it's there. I'll maintain it. On the ground floor this column is there, but on the first floor it's not there. How about in B? In B it shows that this one is coming out. It's sticking out this column. Let's see if we can put it in the other direction, like a portrait type of orientation. I'll come here. I can see that there's a window. You see? Oh, actually here it's good. Let me try to delete and then I'll undo. Okay, the architect left space for us to work. So if we put it in portrait, it will cause a lot of confusion. I guess we'll have to maintain it like this here. So at B we'll maintain it like that with an eccentricity of 0. This is the first floor. I'll go to the first floor there, and I see that at, just give me a minute, at B here the architect will just have to understand us with this protrusion. There's nothing that we can do. So I go to my B1. B1 is column B1. Okay, column B1 is this one here. This one, these, all of these are column B1s. But the architect has put a window here, so I wanted it to face in the other direction, but I cannot change. And also I cannot just take the risk of just having it run on that span. That's too much. I think it's even more than 8 if we confirm. From, suppose we were to ignore, okay, from there to there, suppose there wasn't, it would be about 7.4. Oh, 7.4 is actually smaller than 8, but we'll maintain anyway. I'll delete that. There are no other columns that are coming out here, so I'm good at B. How about C or B1? B1 also, there are no columns that are coming out. All of them are hidden in the wall. 1 2 3, 1 2 3. Okay, how about at D? At D I can see that there's one here right in the mid. In fact, before we go to D, we need to check C. C, we've got these that are coming out at C7 and C5. We've got these two. Can we put them in the other direction here? How about if we put them? Yes, we can put them in the other direction. So what I'll do is I'll go like this. I'll select, and then I'll rotate at 90 degrees. I'll pick it from there and change it like that. I'll copy or move and then put it here like that. So I've changed the orientation there just to accommodate the ones that are coming on top. I'll do the same thing.
But now there is
uh,
on the ground floor there is a door.
on the ground floor there's a door.
Yes, on, is it C5? I think 5C. Yeah, I think 5C.
5C, the door is here. On the ground or the first?
On the ground floor.
Double check. For me it's showing that the door starts here after.
Oh, okay, it's actually D 5D. Okay,
We'll get
it's
to it.
5D.
Okay, I've seen it. This one, right? We'll get to it. So this one I rotated it. Let me rotate this one also because here it's coming out like that. So let me just rotate it at C. We're at C, right? C7. I'll copy like that, including the hatch pattern. When you're copying, remember you also have a hatch pattern. So if you just copy the line, then you've messed it up. So click the line and click any particle in the hatch pattern and it shows. And then you want to rotate. So when you click on rotate, make sure you're in ortho so that it snaps it within 90s. So when I do that, I'll come and copy now and move. I want to move it at the bottom there. So after having done this, I've changed the orientation. I'll now copy them to the first floor so that I can delete the other ones. So I'll click on 5, or I'll pick this as my pick point there like that, and then I'll put here, and you can see that now I have them in that direction. So the ones from before, I'll delete them. Even this one, I'll delete it. Meaning I have to go to my Prota and make the change also. Just make sure you remember it's at C5 and C7. So I go to my Prota. Remember, you're changing all of them. You start from the ground floor, C5 here. Here's my C5. I'll delete it, and then I'll copy the properties of, does it have any centricity? I'll copy the properties of the one that's near there, C5, and also C6, C7 here. Let me just go and check here in my AutoCAD if there's any eccentricity. Yeah, it's eccentric by 100. You see? Even here it's eccentric by 100. So what I've done here is correct, because when I measure the eccentricity, right click, measure from here to here, it shows me approximately 100, but let me do it proper. Measure from here to there, also it's showing 101. Anyway, we'll say it's 100. So let me go to my C1 in my 3D so that I can see that they've changed now. I'll be able to check. See, we're doing what? C5 and C7. So I've got my 5 there, my C is there. As you can see, this one has changed now. And also that one has changed the orientation. So I have to keep it up. I was on my ground floor here. Now I'll go to my first ring beam there, and I'll change. Remember C5, I'll delete this one. You see it highlights there, here. I delete, it goes. I select this one also. I delete, it goes. Now I'll pick one that's got similar properties with an eccentricity of 100, this one. Properties, and then I'll go to C5 here. It shows that it's added one that's similar to the one that's at the bottom there. So C5 and C7 here. See that they've changed. Okay, we've done it on the first ring beam. We can do it on the first floor slab now. I'll go there, change to my first floor slab. C5, this one here, I'll delete. And pay attention there in the 3D. Select, highlight, delete, it goes. Let me just make sure I deleted the correct one. Yeah, C5 and C7 here. Select, delete, and then I'll get one that's got similar properties, that one, and then I'll put it there. You can see the small red color there, it's changed the orientation, and here also like that. Okay, last but not I've got actually two more. Second ring beam there, this and that one. When I select it like that, I delete it. I select this one also, I delete it, and then I'll get the properties of this one. Since they are the same, C5 here it adds, C6 there it adds, C7 sorry, C7 it adds. And then on the roof now, like that, I'll go and say C7, delete, C5 there. You can see it is highlighted, so that one there, press on delete. Copy the properties of this one. I'll put it there and there. Okay. So now I've changed the orientation of all the columns that were coming out in AutoCAD at C there. So now we are going at D. D is the one that's going to give us a problem because there is a door, and then here there is no wall, and then on the other side there's actually even a window. So this is a very big problem. Okay. So let's see at D5. Here is the one that you said there is a door. D5 and D6, D7. So if you had seen 4, are you following?
Yes, I can. Yes, I'm following.
Yeah. You remember when we just started this drawing, we said some of the things we need to run by the architect and ask them to change certain things. You remember
Yes,
that?
I remember. You said
Mm.
to propose to the architect to reduce the door size.
Yeah, thank you. So here we'll ask them to reduce it and move it aside because this one will be too much of a risk. Because here we cannot change and we cannot definitely remove it. Also, this window we cannot change. The span will be too much. So here I'll maintain these two. I'll maintain these two, except maybe here. Maybe they can add a feature or I'll maintain this one and this. Meaning, when I deleted here, D5 and D7. Can I undo? Okay. About see. Okay. D5, D7. Let me check. Also, these are eccentric. Let me go back to my 3D. Check where my D is. Axis D there. 5 there and 7. Oh, here we have one that's running all the way. Oh, except for this part. And also this part. Okay. So I'll go to my roof. This one is in roof. It shows that we removed it on the roof. Story 5 is roof. If you if you check, story 5 says roof level. So I'll copy this one, copy the properties, put it, observe in the 3D there. When I put it there, it closes that small gap. I'll also put it there. Let me zoom like that. I'll put it there and it closes that small gap. But let me just make sure that they're of the same orientation. Good. I go back to my CAD file. We've decided we'll maintain this and we'll try to convince the architect. And then here, there's nothing also. Which one is this one? Should be like E1. Yeah, this is E1. see. Is there an E1? Yeah. E1 there, there's only one column. E1, only one column here. Okay, cool. We'll maintain, although on the ground floor, uh, there's a wall, so it's hidden. This column is hidden in the wall. On the first floor at E1, it shows that there's something like a railing or a glass or something like a balcony. So meaning there is no wall. But then also we cannot just let it run from there, from D to H. And what is the dimension from D to H? This is like 6,300. This is good. But nonetheless, I'll decide to keep this one at E1. Is there anything at E? There's actually nothing at E. Why can't we move it at E? This one will be too short. Okay, you've seen Paul. We can put it at E. This one here. Meaning there won't be any need for E1. Okay.
Yes, at E. I think that will be better at E.
Yeah.
Because then it will be embedded into the wall.
Exactly. So at E here it will sit there. And then these spans also are okay. If we like, we can put another one at E5. E5, will it accept on the first floor? E5 we can accept. Oh. How about we moved these two, we move them here at E. What is the distance from this axis to this one? Yeah, 3, 4. Oh, I want it to go at E. From C1, let me just measure from C1 there to E. How much is it? It's 5 too. So, Paul, this is, I think, a better, we can resolve it like this. The one that's here at the door and the one that's at the
Okay.
window, we can move it here and delete this one. So let me start by deleting this one.
Okay, yeah, because that from E to H is giving me 4,400, which is alright.
You have to move from C to E. Try from C to E. How much is it giving you from C to E?
From C. Okay. It's giving me 5,200.
Yeah, it's giving me 5,200 also. I think it's acceptable. Let's try it.
Okay.
So I'll move these columns. I'll move them from D. I'll move them to
What is the allowable span for this type of columns?
the columns are okay. It's the beams you need to be worried about. The beams that will sit on the columns. So usually
Okay.
between 3.5 to 4. And also there's a formula for span length. It's about is it L over 15 to L over 10 of the span. Let me see. Can I try to? Should I try to open that? Okay, let me see if I can take a snippet. Mm, from the book that I shared last time.
Okay, okay. Check.
When we go to beam design, here we've got flexural behavior and nominal strength of beam sections, chapter 4. So if we go to an example in chapter 4, probably do not waste a lot of time. This book has got ACI, and it's got imperial, and it's got SI examples. So when I go to, okay, here on page page number is this? Sorry, 126. On page 126, there's an example here, and it shows us this. Let's see, shows us the sections, the area of steel AS, the following summarized. Check that they complete the area compression. Okay, corresponding reinforcement. I'll try to. I don't think will be. Okay. I'll try to share something in the group after about calculating the span length, but usually it's between 3.5 to 4.5. You can have a span. A beam with cross section that is 400 deep and 200 wide. It can span from somewhere around 3.5 to 4.5 general. But how you calculate, how you come to that number, I'll have to show you. Okay, let's see. Here we get it in feet. Okay, slide load. Uh-huh. So here there's a definition of clear span. Let me take a screenshot. And then I'll copy it and I'll paste it on the code. And then save this. And then let's see if there's and also it shows a typical continuous flow system there. Okay, here's an example. take off the blades. Okay, this is going to start from page 185. Okay. Hello? You've seen it, right?
Yes, I'll check it in the group.
Okay. So remember, we've moved this on the ground floor to there. So now we also need to move it on the first floor. So what I'll do is I'll just select this and that, and select this and that also, and then I'll pick this point on the corner. First I'll click on copy, then pick this point, and then I'll go here and paste it on this point, and now I'll check. Okay, it's moved there, it's moved there. Both places are ideal, as opposed to having a fight with the architect about the window and the door. This is better. So I'll go to my Prota, and then remember at E1 we've deleted E1. If you go to any E1, you'll see that there's only one column. So what usually happens with Prota is that when you try to delete the axis having certain information, it will reject because it wants you to delete the elements first. Let me show you. So E1 we had deleted it in AutoCAD. We want to delete it in Prota. If I select it, click. If I select it like that and press on my delete key, it says warning, axis E1 is referenced by 25 members, and it shows these slabs. In order to continue, all members using this axis must be deleted. So when you say okay, it means you'd have to go back and delete. So here, to begin with, I'll delete the column, and then what is it affected by this slab? No. Let me try again. Okay, all of them are on story one. So let me start from the ground floor. I'll delete this column and also this slab. This one and this one and this one, and so on and so forth, like that, like that. So I've deleted. Now let me try to delete E1. It shows there are 17 members remaining, the beams and the columns. Okay, still more work to be done. I'll go to the first floor, or the first ring beam there. I'll delete this column. I guess even the beams. Okay, here's not affected. And then I'll go to my first floor slab there. I'll delete this column that's resting on E1, and these two beams that are meeting at E1. Where else? I'll go on my second ring beam there. I'll select this. Okay, I'll carry on as I wait for people to join. So as we wait, I'll delete these other beams here like that, and then finally I'll go to the roof and delete these beams also. Let's see what happens if I try to delete one now. It's saying these slabs in story 1, slab 31 to 36. Sorry about that, it cut. So
Okay.
we received that warning saying in order for us to delete E1, we need to delete the elements that are sitting on E1. So because of that, it's even given us a hint. So if I try to delete, it says associated members. Now everything is on the first floor, story 1. And it says slab 31 to 36. So I need to
Hmm?
go to story.
I can't explain.
Oh, okay, sorry, I didn't turn on. Okay, hopefully you can see it. Let me just go back again. You can see it now, right?
Yes, I can see it.
Okay. So what I was saying is, in Prota, before you can delete an axis, because most of these elements sit on axis. So before you can, if you place things on an axis and you try to delete the axis, it will ask you first to delete the members before you delete the axis. So here, because we found that E1 won't be necessary, we can put those two columns at E. What we found was that when I tried to delete it, it says they are associated members here. Now we've got 6. It says they are on the first floor, or they are on the story 1 here. Sorry, not on the first floor, ground floor, or story 1, because we renamed our story 1 as ground floor. So here it says it's from 31 to 36. So I know exactly what I need to do. I'll just go to the ground floor or story 1, and I'll search for 31, 32, 33, 34, 35, and 36. So here I'll press OK, and then I'm already here on the ground floor, and then I'll try to look for, this is 36, I'll delete it. This is 35, this is 34, 33, 32, and 31. So now when I try to delete it, it goes. Because of this, I'll go to my AutoCAD and check. We moved all the ones that were at D, we put them at E, which is E5 and E7. So on Prota here, I'll just select this one, properties, and I'll put it at here and also here. And then I'll have to delete this one and this one on every. I'll have to delete them on every floor like that. So you can go to your D. I'm surprised it hasn't deleted this one. Delete D7, D5 on every floor. See if you can see it from the 3D. I think it will be better in the. Aha. So you can see one leg is out. If I go to my plan, I was deleting on the ground. If I go to my first string beam, I select my D. Watch the 3D here. It highlights like that, like that. And then I need to, in fact, before I delete, let me use some of the properties of this one. Put at E5 and E7 so that now I can delete this one. Okay. So now I'll go to, I've done first string beam, I'll go to first floor slab, and then I'll copy the properties of this one, and then I'll put it here and here, and then delete this one and this one. I'll do the same for second ring beam there. I'll copy the properties of D7 and put it at E7 and E5, and then I'll delete this one like that. And then finally I'll go to my last one, the roof level. I'll copy the properties there, and then I'll put it at E7 and E5, and then I'll delete this one and this one. I'll Control S just to save it. So now here everything is in order, and then finally at G, okay, at G we can see there all of them are hidden there. How about here? Also hidden, hidden. This one is resting just there. Maybe we can move it in the corner here. Since we've got like a small portion of the wall, and it will sit with this one here. Okay, it can work. So the column at G5 will be moved to H5, and then everything will match now. Let's see. Oh, just selected the hash pattern without the line. I've gone back. No, that's not the best pick point. The best pick point is this one here, like that, and then put it there, and then I'll copy it like that. I'll copy it from here, turn off my snap, and then paste it here. Okay, so there it is. So here you can delete this one, then it will no longer fit in the mid. Okay, meaning I have to go back and change this one. Okay, also this one. We'll start from, we're on the roof. We'll start from story 5 and then go down. So I'll select the properties, put it there, it sits properly, and then I'll delete this one here. Meaning these beams will also need to change. Okay, so I'm good on the last floor there, on the fifth. I'll go on the fourth. I'll do the same, put it here, then delete this one, and this one. Also maybe I can delete this one. Let me go here, go back here, I'll delete this one and this one. You'll have to change. Okay. And then I've done the fourth. I'll go to the first floor. I'll select the properties of this one, put it there, delete this one, this one. I shouldn't have deleted this one. Delete this one and this one. Okay. Also this one. We'll go to the first ring in there. We'll choose to put this one here. Then we'll delete this one and this one and this one. Okay. Then we go to the ground. We choose the properties of this one, put it there, and then delete that one. Okay, so now in our 3D now, even this area now is protected. Previously, it wasn't. So what we need to do is just put back these slabs that we deleted. So I'll select the properties of this one and put it there, there. As you can see, it's closing up in the 3D. Select the properties. We double check it's maintaining a thickness of 120, and then there, 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 and there, like that. It closes. Okay, so here we've closed. Now what we need to do is go to the next level for story, the ring beam there. Here I don't know how it's going to react, but let's try. Meaning we'll put one from there to there, the beam, the 200 beam, and then from there to there to there. We've closed it now, it's like a ring. I'm not so worried about the ring beams because they'll be sitting on the masonry walls after we load them. So now, after having done that on story 2, we go to story 3. Okay, so now the beam system will be like this. Okay, that's the axis. We have to delete the beam like that, like that. Okay, so now my beam system will be like this. It will span from there to there, and then here. It's asking if they need to, no, since I want that one to be my main or my primary, I'll say no. I'd much rather have this one join in that one, and then this one will be the main, like that, there, and there. And then this one can join in this one, it's good. This one can join in this one. I want to see one beam. Okay, I'll delete both slabs, and then I'll change the property here like that. Now we do not have any error message. Okay, this is good. And then I'll select the properties of this beam and put it there and there. I've closed it up now. It's good. So where else do I need to go? I need to go to my story 3. Select it like that. To the second ring beam. Sorry. Story 3. I can see that I need a ring beam to go from there to there to there. And then remember, this one is a sketchy one. It moves from there to there, and then it's supported from there to there, like that. Some is very sketch, you see. And then finally, we'll go to the final story, which is this one. And then we'll delete this one, and this one. Delete this, and this. And then select the properties of this beam. It will go from there to there to there. I'll say no. And then I'll move from there to there to there, like that. And also one here, like that. Oh, we need another one there. Isn't there a column here? Let me check on the in the second one there, first floor. Yeah, there's a column here. Which column is this? It's 4. D4. We have a D4 column here on the roof. We do not. We need a D4 column here. How's the CAD file? Is there a D4? Yeah, there's a D4 column here. And the D4 column there. I don't know why. Okay, go to 3D. Oh, it ends here. Ends on the first floor. There. Let's see. Yeah, that's the one. So on the second ring beam, we need to put a D4 column. I'll go to my second ring beam. Does it have any eccentricity? I'll use the properties here, and then I'll put it there. Let's see, are they the same? Yeah. Okay, how about here? Yeah, similar. It's got an eccentricity of 10. There. D4. I'll put it here also. D4. Okay. I think it's the same there. If it doesn't come and give any issue. They're just generating. I'll delete this one. Let's see the properties here. -1. Oh, okay, that's it. In this one, -1, good. How about if I select it, I click it, and generate it? I generate it there and there. Okay, completed. Okay, it's there now. So if I go to my roof, I can see that it's there now. And I can put the beam like that, and then it will be good now. So how about here? This is number 3. 3, D3. I go to my D3, should be a column also, D3, D3, so there's one here, the second region, there's one, but on my first there is, I'll generate it, there and there, okay, this one, yeah, so this one is there, I'll go to my first floor slab, I'll select this one, properties, put it there, and then I'll go to my roof, how about my first floor, and my second region, there's nothing, properties, put it there. Okay, now it's working as it should. just do a visual inspection here. I don't know what happened. This is what B3. B3 is one there. Okay. What is B3? Is it? Yeah, B1 3. Okay. We go to the AutoCAD file. We check B13 has a column here. It also has a column here. I don't know why it wasn't generated. In fact, all the elevator the staircase, they were not generated. Okay, I'll fix that one. I'll fix that one. Also generate here and here. Oh, see what the problem is. So just for this one, I'll go to the roof, and then I'll select this one, properties, and I'll put it there. So now we're good. If we do a visual inspection, you can see like that. But then here we have a problem. See the roof, the roof height. Oh, because we need 4 to 7. Five is the column there. 5 is the column there. 5. So we go to filter, check Y. Oh, this one here. Generate. This one. This one. And the wood. See the first floor. So go to this one, first floor. Okay, it's got 100 eccentricity. Okay, and the second ring beam, and which is this one. Properties, put it there. As you can see, it showed up now. And then on the roof also, I'll use this one. Then put it here. Okay, so now it closes up that block that we were seeing. Okay, just do a visual inspection like that. Okay, we are good now. Go to the story 5 and add your wall, like add your slab like that, like that. Okay, Control S, you save. Okay, so before I close this session, let me just do the analysis real quick, and then we'll see what will accept and what will fail, and then tomorrow we can try to work on what will fail and also load it. Yes, it's good. The system looks good. Okay. floors have been populated. I'll cancel this, maximize this, and then perform a real quick analysis. I'll go to analysis, building analysis, and then this is a pre-analysis. The parameters, lateral foundation, change to 150, give it a very low bearing capacity like that. Lateral loading, all this is good. Lateral drift, can give it a title, okay. Load combinations, you can generate. Vertical, okay. Horizontal, just a notional. Vertical, just a Q or the G. Here it says 1.4, 1.6. You say okay. They generate there and geofate.
You said Q is the live load.
It's G. Let me show you. So here, create and factor G plus Q. Also here it says dead load is the G, live load is Q. You see?
Okay.
Mm.
Okay. Okay.
So here your G is a dead load and it's given a 1.4. And then your live load is Q, it's given this 1.4. And then when you go back to this book, there was somewhere here, you see. For it, it uses 1.1 and 1.6. But BS uses, let me just take a screenshot. For gravity loading and typical maintenance stress system, the required combination of factors load should be determined for the first two equations. Assuming that the loads due to fluid pressure is related. C can be ignored, the factor by combination should be. But one can specify at D and K. Okay, so there you have 1.4, 1.6. Same as Prota there, 1.4, 1.6. So let me
Okay.
just take a screenshot here. Load combination, this is the what? This page 184. Can review here. So 184 gives the load combination. Okay. Okay, so here we're good, right?
Yes.
And then we can change the material. Do I have to design using sequence 5? No. Let me edit real quick. I'll start with the foundation. I want it to have a C30. I can add one and then I can rename it material, say C30. Make sure to change the compressive strength to 30, not 25. The density remains the same of R624. We can confirm that. Modulus of elasticity remains the same. Okay, tensor remains the same. All these other elements are changed. And then I'll say apply to all members like that. Here remains the same. Okay. So my grade of steel I want it to be minimum 460. Can go above 460. Also this one 40. In fact, why didn't I just say apply to all like this? Okay, here it remains apply to all. And then for my foundation, the most that I want it to use maybe is 16. So 16, I can use 16, I can use 12, and I can use no, 12 and 16 will do for the foundation bases. And then for the links, I'll use 8s. I just want to use 8, not 10s. Okay. And then I can go to default material here for concrete columns. select C30, apply everywhere, you say okay. If we've got any steel, I'd much rather we use 355, apply to all. And then for my reinforcement, steel reinforcement minimum 460 Newton millimeter squared tensile strength. Oh, also I forgot to change the bars. Much rather it says my Y rather than a max. Apply, I say yes. Let me do the same for the foundation. Okay, so Y also change. Okay, rebar for my concrete columns, I want a minimum of these are 200 by 400. Okay, I can use Y12, minimum Y12, maximum Y16. I do not need these other ones. Section is too small to have Y40 of it. So 12 or 16 for my columns. Okay, and then I've got no walls. I can leave that. For my beams, since they've got a 400 depth, I can say you can use either 12s, 16s, or 20. I don't need 25, I don't need 32. So this way. Okay. For my slabs, either 10s or 12s. Either a 10 or a 12. Okay. For my ribs, I've got no ribs. For my links, all of them I just want them to be 8. Save on cost. Okay. So 8 will do. Okay. So now I can select OK. I've got my material. Auto analysis, you can use the default setting. Here is 30 degrees of freedom, X and Y. You do not reduce anything. User-defined supports for soil structure interaction. Stiffness remains the same. Slab module, you maintain it as is. And then you go to your analysis. You perform a building check. Let's see if it's got any errors. Okay, I'm surprised. It doesn't have any errors. Okay, good. And then we'll say column beam. I do not want it to reselect, because if it reselects, it might give me 14. I'll start the analysis. Okay, we are good. Difference between decomposed loads and slab loading is 33. So this is something that the error message that you are getting, right?
Yes.
Ah, so when you click OK and OK, when you go back, you select your design here, design status. Oh, actually, just these are the ones that have failed. Even this to Manankan, the marine beams. But for this, we can come and try to clean them up tomorrow, because we'll need to add loading. For example, since most of my beam loads here for the foundation here will have the strip footing, right? So all the loading for my wall in this area will go to the strip footing, right?
Yes.
But for this first floor, it will go to the columns. So I need to load it like that. I can select it, right click it, and say define wall load. If I click define wall load, it says the wall load of an existing beam should be copied. Define or edit beam wall load. When you click on it, it brings you this. You can either input this manually, or you can go this side. So you want a wall, cool. But then what kind? In tomorrow's video, I'll show you how to calculate the load for a 6 inch or an 8 inch, since we'll be using 200. But here, because here it uses bricks, and these bricks will be far much heavier, right? But the hollow blocks, you have to factor out that void. So just for this example, maybe I can use, okay, let me try to use 200 now. I'll say 200. And then it says this, it's calculated the unit weight in kilometers per meter. But it needs the wall height in order for it to give the whole calculation. And then if I remember correctly, let me go back to my, these walls were in 4 meters, isn't it? The height. Oh, my video set out as a matter of fact. I think that was like 4 meters, wasn't it? Let me check this section from the ground floor to the first floor, saying 3.4. Anyway, we'll see. Let me use 3.4. Here, it's in meters. So I'll say 3.4. And when I enter, it gives me this loading here. It shows me. And it says what area there, what. When I click OK, the following analysis and results will be invalidated. It will be invalidated because now I'm loading the beams. When I say OK, you can see that it's gone way further. So I need to reduce it to meet the ring beam there. And then what was the ring beam? It's 2.4. So this I need to edit it again to say 2.4, and then I'll say enter and OK. You see now that it reduces, but then again I need to remove that 400 so that it can just meet there, because now it's entering the other one. So when I click it and edit it, it just has to remain as 2, like that. And then you'll see that it will rest. Oh, maybe 2 2. Sorry, 2 2. Aha, 2 2, it meets right in there. And then you can decide to load your ring beam also if you like. Personally, I wouldn't, because it will just be sitting on the blockware. So there you click again, you say edit beam load. Remember, what did we use? Did we use the 200 here? Let me check. Edit. We use the unit weight of, yeah, 200 brick. So here also you select it, edit beam, you use 200 brick. If you like, you can copy. So you use 200 brick, you say 2.2, you enter, it gives you, it comes like that. So if you do not want to go through all that trouble, you can select that beam and say copy beam model. Then you can click on this beam and then you can paste it. You can say paste copied beam model like that. And then when you click like that, it comes. And then you can do the same for these other ones. You click, you select and paste, you click until you go around, you load them, especially the external ones, because they're the ones that are going to be solid, to have solid filled blocks like that. And then if you like, you can decide to rerun the analysis after having loaded with the 200 bricks. How long is this video? Okay, just 149. Since we can maintain all this other stuff, we go to analysis. You can try to perform the building check. No errors. Just say column reinforcement design, beam reinforcement design. Still member, though we do not have still, we leave it. We start, and then it loads like that. say okay. Okay. Now it doesn't even give that decomposed message now, you see. You close and then you can change your beams now. It's saying thread. So when you go to beam design there, it gives you this error message. But one existing skill is not sufficient. Do you want to reselect? You say yes. And then you check what it gives you. It's saying two white walls, two white walls. Already this is failed. And then when you go to detailed drawing like that, it will show you 16, 12, 12. We can't have two white walls. That's insufficient. And then it also gives you a cross section of 400 by 200. So what you need to do here is just bump it up. Instead of two white walls, you can bump it up to two Y16s, even at the top, and two Y16 at the bottom. And you see, the red is going out. So you do not want to have red numbers. Red numbers are they're danger. So when you put like that, this one you put like that, these disappear, but then this does not. So maybe you might want to have three Y16s. But even in that case, only these are changing. So you maintain, and then maybe you give this three in the middle. Still, if it does that, okay, go to the bottom. Only the bottom numbers change. And if you want, okay, put three. So where can we add more reinforcement? Can we add it here? It's changing. Okay, so in the middle we put three white walls, and then at the top there, like that. Also we can do the same here. You add two accepts. Okay. And then this one also you change to Y16. This one you change to Y16. This one you want 12 or 16. Three accepts. Here you change, you want 16s. Also here you want 16s. Okay, like that. And then when you check the detailed drawing, it shows that you've added extra. For example, between H and E, in fact it starts A, B, C, D, A, B, C, E, H, and then it cuts. This section, oh, before you do that, check. This section is somewhere here. For example, where we've added extra reinforcements, it's BC. So here I expect to have more, like that. So BC here, when you create a cut, I expect when I look at BC here, it's got more reinforcement. But I do not want it to be cluttered like that everywhere. I need it to come to the bottom. So I'll show you more. You can check the diagrams here, envelope diagrams, either bending, the shear, you can change. So right now it's showing a moment diagram. You select shear, it will show you, and then when you select the loads, it shows you, and so on and so forth. If you like, you can print. If you like, you can recalculate, and if you move like that, it shows you the X, and the minimum and the maximum. So when you exit, after having cleared, you do this, you see that it changes to green, like that.
Okay, makes sense. It makes sense now.
So also this one you can select, you go to beam section design, already it gives you a warning. Why it's giving warnings is because some of them are white walls. Let's see if I can have 16, 2y16, 2y16, y16 there. I want 16 there, 16 there. I do not want a 20, but it seems as if I do not have any option. How about if I add another one there, like that, reduce to 16, and then maybe have one, two. better to have the same bar. Instead, somewhere 16, somewhere 10, and then you have a 20. Even when you're buying as a client, it becomes very difficult. So better if you're using 16s, you use 16s. If you're using 12s, you use 12s, and so on and so forth. This one refuses. Okay, so 116. 2 accept. I don't know why I didn't change that one. 16, 16. And then you can check the drawing there, you double check like that. It shows your A is at the bottom, B is at the top, C is the link. You see it even says Y8. So you say okay, and it changes. So this one has changed, and this one has changed. Just these. So you can try to do that even for the top ones. So in addition to doing this in 3D, you can also do it in 2D. For example, I know this is on the first floor. I'll just go to the first floor, change the plan, and then it shows me. So I select one like that, and this is better because you get to see all the warning colors. Go to beam section design. This one is good. What colors were there? Oh, what bars are they? Choosing 12, but much rather use 16. Okay, 16, 16, 16 here, 16 here, 16, 16. No red. Okay. Then do the same and so on and so forth. So Paul, you can try to change them. Let's see if we've got a column. Yeah, there's a failed column here. If I select it, I'll go to column section, and then I can see that oh, the utilization ratio is what India was talking about. Here I can see that it uses Y16 is 3. Gives me the eccentricity. If I say okay, I move away. Still red. So what I can do is I can reset the bus and then give them the numbers that I want. Y16s. I cancelled. Sorry. Column. I'll reset. Then give them the ones that I want and say okay, and it changes. You do the same for this one. If you reset it, you give it 16. Okay, it's good. You go back. Bear in mind these are still red. So you need to go in and then find out. But the bottom ones are good. Okay? And then the other ones are good also. If you check this other one and you go to column section design, it also shows. So you change it to 16, 16, you okay it. It's accepting. I'm at 12 because we haven't loaded it. So you change this to 16 like that. Hopefully you understand.
Yes, I understand.
Okay. Then you can go to the ground floor also. First room, then check if there are any ones that are, and so on and so forth. until everything is green, until you make all your changes. Then and then you can put them on a paper. So tomorrow we'll finish loading the beams and then we'll add the foundations and then we'll try to export it to DWG. Then we clean it and put it on a paper for presentation. Okay.
Okay.
All right. Thank you.
Okay, okay, thank you. Good night.
All right.